Hello, I'm Mel Grubb and welcome to my course, Creating Maintainable Contexts for Automated Testing. I'm a software developer from Columbus, Ohio, focused on code quality and developer productivity. As an industry, we've all agreed that tests are vitally important to the longevity and maintainability of our code, but often the simplest of changes can cause an avalanche of broken tests, pulling us out of our groove to wade through complicated test contexts that we didn't write and may not fully understand. In this course, we're going to explore ways to factor out commonalities from the test contexts using the object mother and object builder patterns so that you can clean the clutter from your contexts and let your tests focus on what's important. I'll even show you how to automatically generate the majority of the builder's code so that they stay up to date as your project evolves, and you can get back to working on the interesting stuff. This is an intermediate testing course, so you should be familiar with C#, MVC, and testing frameworks such as NUnit. By the end of the course, you'll have a toolkit and the know-how to write tests that clearly communicate their intent to other developers on your team, including future you. I hope you'll join me and my course, Creating Maintainable Contexts for Automated Testing, at Pluralsight. In this module, we'll take a look at a typical line of business application, its test suite, and the fallout that results when business requirements change. As you're well aware, software is a complicated business. Even the standard example of a customer, their orders, items, and products can quickly turn into a vast hierarchy of objects. Writing tests for just one of these components can quickly end up involving many more of them. And when the requirements for that component change, it can have wide-ranging repercussions for the rest of the system. A normal business-driven change to one part of the system can break even the best testing suite in unexpected ways. Let's take a look at this scenario in an actual solution. We'll start with a quick tour of the solution we'll be working with in this course. Here we have a typical business application representing a store, its customers, and their orders. It has all the things you've come to expect from a line of business application, broken up into a number of tiers. There's the common assembly, where we define objects that need to be shared across all of the layers of the application. There's the domain assembly, where we define the business objects as well as an Entity Framework core code-first DB context. For simplicity, we're going to assume that all domain models have an integer identity column in the database, and that products only have a single category. I'm also going to consider authentication and authorization to be outside the scope of this demonstration, but I do have a user object here that represents the users of the system, typically its customers. The domain layer also houses our repositories, one per entity type, inheriting from a generic repository base class. Real-world solutions are obviously more complicated and may be split up into more pieces, but this will serve my purposes just fine. We have a service layer, where the business logic lives. It has a service for each type of entity that we want to allow API access to, as well as some object mappers. They're using AutoMapper internally, but that's just an implementation detail and not important to this course. There's a WebAssembly, which is a combination MVC and Web API project. I won't be building out the web part as it's outside the scope of this course. The API controllers expose the services as REST endpoints and are documented by a Swagger page generated by Swashbuckle. For example, here's a status endpoint that lets me see the version information for the API. And here's a list of all the addresses in the database so far. Again, this is not essential or required for this course, but it gives me a nice UI to view the public REST API. And finally, we have our unit tests. I'll be demonstrating how thoughtful test context design impacts the maintainability of these tests as the business requirements change. The approaches we're going to build in this course should work with any testing framework, so whether you're using raw NUnit, XUnit, MSTest, or a BDD framework like SpecFlow, you should be fine. I'm using Matt Honeycutt's excellent Specs4 library in my unit tests, because it will help me skip over the ceremony and spend my time on the contexts, which is what this course is really about. If you like the style of these tests, Matt has a Pluralsight course on Specs4 which I recommend checking out. In addition to Specs4, I'll be using NUnit as my testing library. It's the oldest and most universal testing framework in the .NET space, so it should be familiar to anyone who's done any testing at all. I'm using Mock as my mocking framework for similar reasons. Mock may not be the oldest, but in my experience it's the most widely used. And I'm using the Shouldly assertion library because it keeps my assertions independent of the testing framework and also makes them easier to read. These are just my personal choices and none of them are required to complete the course. Back in Visual Studio, we can examine the unit tests. Right now, all of my unit tests are passing. I'll be concentrating on repository tests executing against an in-memory SQLite database, which gets us true relational behavior in a disposable database. Technically, this makes these integration tests, but I'm going to bend the definition a little here since we're using a throwaway database rather than the real thing, so it's kind of like a mock. As you can see, they're simply testing the system's basic CRUD operations so far. That is, the ability to create, retrieve, update, and delete entities. You might not normally write unit tests for these operations, but they're perfect for this demonstration because they'll let me break things easily later on without having to set up any complex business processes. Foreign keys are all I'll need for this demonstration. I won't be covering integration tests in this course, but the same approaches and techniques would be used in either kind of test. Likewise, the architectural design choices of the solution aren't what we're here to discuss, but having a more or less typical solution should help you relate to the testing issues you may have run into in your day-to-day work. It's not a fully fleshed out solution, it's just enough to demonstrate the problem we're here to solve. But feel free to poke around and explore all you want. Let's return to our example scenario. Up until now, our sample business has operated solely within the United States. It's always been a small shop, but times are changing and it's time to grow up and go international. The system wasn't designed with this in mind, though, so we're going to need to make some changes. To pull this off, we're going to need to add a country table and assign each state to a country. In addition, the business needs to account for terminology differences between countries. For example, Canada doesn't have states, it has provinces, and the term zip code won't be meaningful outside of the United States. So we'll add fields to country to hold the appropriate terms. There are other differences like phone prefixes, formats, etc. But really the only thing we need for this demonstration is the addition of the country class and the foreign key reference from state.